Okay, objective for this part of the lesson is to understand the power supply, specifically what it does, what we're looking at. We're going to have an article or two that we're going to read after I go through this, and a video at the end of class as well on understanding power supplies. Power supply changes that AC voltage coming out of the wall, again, alternating current out of the wall to that direct current that our electrical components need inside our PC to operate. There's a ton of different looks and makes and models and manufacturers of power supplies, but they have some basic similarities. They all turn the same AC volt and the same amount of DC volt. They can have different kinds of fans, different sizes of fans to help cool our PC. They can have different numbers of plugs that are connected to it. In fact, a lot of times we buy a power supply specifically to meet some requirement that we've got that's going inside our PC. So we've got some plugs that come out of the back, and those plugs, although they all have the same voltages, we can have different numbers of those plugs coming out of our power supply. They're not all the same. We already talked about volts times amps equals watts, and the power supplies are rated by the total number of watts that they put out, because they can have more cords and plug in more things depending on how good the power supply is. They all have a P1 plug, and that P1 plug goes to the motherboard, and it either has 20 or 24 pins. This one in this picture is a 20-pin power supply, and I showed you last class how they can have B20, 24, or they can be 2024, and they can slide off the other 4 pins. And if I'm going to buy one, I'm always going to buy a 2024 because I want it to be completely versatile. I want it to work on any motherboard. So if I get a 20/24, then I can slide off those extra 4 pins and I can plug it in any kind of motherboard. So all of them have one P1 plug, only one. Most of them today, and this is the P4 plug. And if we don't know what the voltage is on the, oh wait, let's go back to the P1 plug. The P1 plug, again, what's the voltage on that? 3.3 volts. That's kind of hard pausing when there's actually no one in the room. But I'll pretend you're all there shouting out 3.3 volts for that P1 plug. Okay, then we've got a P4 or a Pentium 4 plug. Realistically, every computer today is Pentium 4, dual core, quad core, 6, 8 cores. They pull more power. Okay, sorry about the interruption. So we've got a P4 plug. If we don't know what the voltage, what is the voltage of any plug we're not sure about? It is, again, pretending you're shouting out the answer in the middle of the class, it is 12 volts. If we don't know otherwise, it's 12 volts. It's 12 volts if we don't know otherwise. Okay? This isn't on any power supplies I've ever seen. I'm going to skip that 3-pin fan one because it doesn't actually, I've never seen one on a power supply. The next two both go, either it's an SATA or an older drive, depending on which one. But these are the connectors for the hard drives, CD-ROMs, anything that spins that requires more power. And again, the voltage, if it's not otherwise, it is 12 volts. And the last kind of connector we have is the floppy drive. It's a 4-pin connector that looks just like, I'm sorry, it doesn't look just like any of the connectors. It's smaller and it uses 5 volts. Okay, so we've got these different voltages, and the amount of power that thing pulls depends on the amount of current that pulls through it. And so we've got different wattages, the different things that plug into it end up pulling out of our power supply. So all those things together give us specific wattages that pull out of our power supply. Okay? We're going to talk about buying those in a minute. First, we're going to talk about some problems and some things we need to think about as far as power supplies. Now, if we've got a power supply that's too low voltage for our things that we've got in it, or if it's gone bad, we may need to upgrade and swap out that power supply. Next class, we're going to be pulling power supplies and putting power supplies back in, testing them while they're out, and then reconnecting them in all the PCs. We're each going to do 2 or 3 during the class period, so you get used to pulling and replacing power supplies. It's going to be necessary when we add new devices and go past the wattage of the one that's in there, or anytime it goes bad, and we have to be able to estimate how much wattage the PC requires in order to determine what power supply we need to upgrade it to. So, before we change out our power supply, we might want to troubleshoot the one we've got, and there's some things that can happen. I will tell you most of these I'm not gonna worry about. Their power supplies are pretty darn obvious most of the time. Most of the time they just don't boot up. You know, if it comes on and then shuts off, okay, so it boots properly, but then runs for a while and turns off, and I talked about that last class, that if the fan goes out on a power supply, then it's going to overheat the system and it's going to make the system shut down. So that's kind of, it starts up normally, but things go wrong from there. If we ever smell any electrical odors coming out of our PC, most likely it's the power supply. And the one thing you don't want to do is stick your nose in the power supply and sniff it as hard as you can to see. I have had an engineer when I was flying 53s that was looking for electrical odor and climbed in the bay between the pilot seats, trying to find the electrical odor. It was an electrical motor that had gone out and fried, and he ended up passing out with his legs halfway out of the electrical bay in the MH-53 helicopter. I wouldn't recommend doing that. It's bad for you. In most jets, the first thing you do if you see smoke and fume elimination, you're supposed to oxygen 100% and stop breathing any of the air because you can lose consciousness from it. So if you see smoke and odor, do not breathe it. Get the component unplugged. If there's open flames, obviously treat it like there's a fire in the building. But if there's no open flames and just some smoke, we normally just unplug it and then air out the room. I've got an exhaust fan in the back of the room that we can turn on. And you want to get away from that smoke and get that room aired out, okay? So if we turn it on and there is smoke, that's what we're going to do. We're going to unplug it right away. Anytime we plug one in and we're testing because we think there's a power supply problem, if the PC doesn't turn on, if the tester doesn't come on, unplug it from the wall and remove that electrical power. Just because there's no indication that the power supply is working doesn't mean it's not going to catch fire. I have had a student use the power supply tester, which you're going to use next class with me. On the power supply, no lights came on. And so they left it plugged in. And it was a student that was trying to fix a PC, and I was across the hall starting to image stuff. He comes over me, and when we walked back in the room, the power supply was on fire. So we're not going to ever walk away from electrical equipment that's plugged in if it's not a totally enclosed PC that's working properly. Other than that, if I plug something in to test it, I'm going to immediately unplug it and stop that, okay? So we want to make sure that we don't do that. Whenever we're looking at it, we make sure we turn the computer off, we unplug it to check those connections to the power supply. Sometimes just unseating the power supply and reconnecting to the motherboard can solve our problem. Some things just happen and has to be reseated, and that sometimes fixes it. When it's connected, we look at the fan in the back to see if the fan is turning. I already mentioned that. It can cause it to overheat. And the other thing is that we have to make sure the remote switch, the turn-on switch, is still connected to the motherboard. That has never come unplugged on a PC when it's enclosed, ever. That's I just put in a new motherboard and I forgot to hook something up problem, not a I'm troubleshooting one that's already working problem. So there's those wires that connect to our motherboard, one of which is what turns on our computer, and if we don't have that plugged in correctly, it will not turn on the power supply. But it would still work with the tester, so that would still be a good test to use the tester. Okay. Fan says it might be a symptom of another problem. It's a symptom of overheating, and what's the maximum temperature we should ever see inside a PC before components fail from Chapter 1? The maximum Fahrenheit temperature before electrical components begin to fail is, this will be on the test, 185 degrees. Okay, temperature is above 185 degrees, so electrical components fail. So if it gets above 185 degrees, it's probably going to the PC is going to shut itself down, or components will start going out. Oops, I went the wrong way. Okay, overheating could hang, could shut down after it's been running for a while. We want to check the airflow in the case, check the vents, and we can go through BIOS, and some BIOSes will tell us what the maximum temperature was reached of the PC. We can see that as well. One of the things we can do about overheating is to add another fan. All fans in the back should blow out of a PC. None of them should ever blow in. If you put a fan in a PC and you forget that and you have it blowing in, what did I just do, and I have it blowing in, then what I'm going to do is get a temperature loop, basically. This hot air is going to blow out here and it's going to get sucked straight back in. So now we're pulling hot air into our PC to make it hotter, and we're just going to be circulating that hot air around the PC. They should all go out of the back of a PC. This fan should blow out. This fan should suck through the PC and blow out as well. A well-designed system has vents in the front, pulls air across the CPU, and it goes out. Pulls air through the power supply and goes out. That's how a well-designed system works. Now, if I've got wires clogging up and in the way in my whole system here, okay, interruption number 2. So if I've got wires inside my PC, they're all gunking up here and they're going to block the airflow, that's when you'll see people use zip ties and tie all the wires up out of the way, did it again, out of the way of the airflow of the PC so that it doesn't block the airflow. Okay? So we want to have good airflow on our PC to keep it from overheating, and overheating obviously is a bad thing for our PC, and that's when, I did it again, and that's when we can get those components overheating. And I showed you that video last time, the time before, about the CPU blowing up if the CPU fan was pulled off, and that's one of the downsides of the heat in the computer, and that's why we need to get it vented out through our PC. Okay, so that's number 2. Now we're going to read a couple articles on the power supply. There's a power supply myths article, and you'll see it on the Moodle assignment in general. You're going to read those articles and then do the written response to those articles next for the rest of the class. And then there's a follow-on video that you're going to need to watch before the next class. If you have time during this class, that's fine. If not, it is homework prior to doing the next class, and there is a reading response to that one as well that you have to have done prior to the next class.